We're going to be taking a look at ways you can improve your environment if you have Pure in it, and some ways that you can optimize things and make sure that you don't have anything that deviates from best practices. And one of the things to bear in mind with a flash array is that internally there's not a lot of dials or levers that you can manipulate within the array. There's no RAID groups, there's no tuning, there's no storage pools that you have to constantly keep in mind. So a lot of the ways that you can get better performance and more resiliency out of your flash array are things that are external to your flash array. One of the biggest is port balance. If you follow Pure's best practices on your target ports and you're using all of your flash array fiber channel ports, balance should be a relatively easy prospect. The only real reason you would want to have a major disparity in your target ports is if you have initiators that are more than 2 full port speeds away from the targets on your Pure array. And in that case, you'll want to carve off a subset of your flash array ports and downclock them a port speed to make sure that there's no more than 1 port speed disparity between the initiator and the target. Something else to bear in mind with your port balance is that there is a maximum number of initiators that are supported by Pure. Your flash array C supports 500 hosts or 1,000 WWNs per port, and your flash array X supports 500 hosts or 1,000 WWNs if you're at purity 5.3 or greater, but it does jump up to 1,000 hosts or 2,000 WWNs if you're at purity 6.0 and higher. So this is one of the charts that are generated by IntelliMagic Vision. And what you're looking at is a 4-port flash array and how your front end response time is behaving on it. As you can see, it's got a green border around it. IntelliMagic Vision uses a stoplight metaphor where green is good, yellow is a warning, and red is an exception, a performance exception. And how those manifest themselves is if a particular metric, in this case your front end response time, spends most of its time in this lighter area, that is where things should be. So your border will be green. As it transitions up into the slightly darker area, that's your warning track. It's not necessarily affecting performance, but it is something that you want to be aware of because you're starting to push the limits of your device. And then as the metric gets up into the darkest area, that is where you're getting into performance exception. And so the color of the border will transition to red to draw your attention to the fact that you're past the recommended levels for the device. And the reason for the jagged lines, this is one of our charts that have variable thresholds, and those variable thresholds are taking into account multiple different factors. So we're looking at not only the configuration and capabilities of your device, but we're also taking into account things like read and write sizes, what's going on with your speeds and feeds, and what's going on the back end of your array to come up with our determination for the health at that particular time interval. So as those things change, then your thresholds will shift as well. So we're looking at the front end performance now for one of the flash arrays, and you have one volume that's highlighted here in bold that is contributing most and experiencing most of the front end performance issues. And that's also highlighted by the rating for that particular volume. We use a rating of 0 to 3, where 0 is things are as good as they can be, and 3 meaning that there's a very high likelihood of impact to your environment. This one's rated at 0.64, so that's definitely something that one would want to investigate to see what's going on with your performance on that volume. We also need to keep an eye on your front-end performance in terms of ports by throughput. This is a chart showing that how each of the 4 ports on this particular array, it's only got 4 that's configured on it. You can have many more by how you configure your slots on the back of the storage array. This particular one only has 4 fiber channel ports. You can see that they're fairly well balanced as they come across. None of the ports are in any danger of being saturated. You also need to be aware of who the heavy hitters are in your environment. So whether you're looking at, in this case, at your hosts and your host groups, your most active volumes on your flash array. This chart is showing you in a bar chart which of your volumes are the most active in terms of IO intensity. You also need to be aware of what type of activity your top hosts are being used. This breaks down your highest throughput volumes by read and write throughput as well. Another thing to be aware of for good monitoring of the performance on your flash array is determining if things have changed and what the magnitude and significance of that change is. The way IntelliMagic Vision does that is it looks at your key performance indicators for what you're looking at. It does a 30-day baseline for each key performance indicator and then uses statistical analysis to compare your current day's performance to that 30-day baseline. And it manifests that statistical reporting in terms of standard deviations. So what we do is if the rating is less than 2 standard deviations, then it will not highlight that metric to bring your eyes to it that there has been a change. Between 2 and 3 standard deviations, it will highlight these as yellow, bringing it to your attention that you've had a fairly significant change. And if it's 3 standard deviations or greater, then it'll flag that as red, indicating that you've had a quite significant change. And bear in mind that not all change is inherently bad, but it should be noted because it could be a sign of a new workload that you're unaware of or an unwanted change in your environment that's causing a performance change. So what this is showing is all of the key performance indicators for your performance for a flash array zoomed in on one day's performance. So the green line here is your 30-day baseline. And these other colored bands here are your greater than 2 standard deviations and greater than 3 standard deviations here. So we make it easy to see how your current day's performance is compared to the baseline for the past 30 days. So common issues, as we mentioned earlier, front-end port imbalance is a big thing to consider. And you also need to bear in mind the limitations of 500 hosts or 1,000 WWNs for a flash array C, and a 500 or 1,000 WWNs for a flash array X at purity 5.3 and greater, and 1,000 hosts, 2,000 WWNs for purity 6.0 and higher. After that, like I said, a lot of the things you can do to improve your performance are going to be things that are outside of your array, like how your fabric is performing.